To try to motivate this idea, let's look at a little example. So let's imagine we've got two agents, Agent 1 and Agent 2. And Agent 1 has a kind of a goal or some kind of reward function that it's running. And to make that reward function have a high reward, Agent 1 needs an apple. Now, the apple's not far away, but it is very close to Agent 2. So what are some things that Agent 1 could do to satisfy its goal?
It could walk over to the apple.
Good. Anything else?
Well, once it gets there, it can say, I thought you were giving me an iPad, and then kick Agent 2 and run.
I see. Wrong apple. This is the food kind of apple. But you're right. Probably this particular Agent 1 would like an Apple Watch.
Yes. Well, actually, this particular Agent 1 has an Apple Watch. Then let's see. The other thing that could happen is Agent 1 could ask Agent 2 to bring him the apple.
Good. And I guess presumably Agent 1 could just do nothing and just wait for Agent 2 for the apple to just show up.
That's usually how it works.
Like, maybe Agent 2 would bring it by. I guess if maybe not apples, but like almonds. There's certainly agents that bring Agent 1 almonds.
And ice cream.
Yeah. Have you gotten ice cream in a while?
Yeah.
Okay. Then yes. Okay. That's too bad. Looks like your Apple Watch exploded. My bad.
That's okay. I'll just get another one.
Yeah, because this one's broken. Anyway, when we're doing planning or sequential decision making, we need to decide amongst these different options, if you will, or different courses of action that we could take. How do we usually do that in the frameworks that we've been talking about?
Well, if we're living in an MDP-like world, we actually define the MDP, and I think the secret sauce there is figuring out what the right rewards are. Right, and the reason I said it that way is because in the game theory case, we usually call those utilities and not rewards, and I just want to differentiate between the two of them.
Okay, and then what do we do with those?
Well, once we have rewards or utilities, we then find a policy that maximizes them. We maximize our rewards or utilities. Or actually, I guess we maximize our utilities.
It seems like we can do this sort of thing in the scenario where we've got multiple agents and they need to coordinate and communicate with each other. But it turns out it starts to get a little bit hard to define exactly what the costs are and what's the likelihood that this is actually going to work and so forth. So what we're going to do is actually think about, just like we did when we talked about POMDPs, we said that they allow us to strike a balance between actions to gain reward and actions to gain information. And we didn't have a special other way of reasoning about that. It all ended up being folded into one model where actions are being taken and they might have informational impact and they might have reward impact. The informational impact is subservient to the reward in a sense, right? So the agent just tries to figure out, I will take an action to gain information if it helps me get more reward in the long run. And so this the DEC POMDPs is a similar sort of idea that's going to let us put coordinating and communicating along with actions, that they become actions just like everything else. Like this ask for it becomes a kind of action and walk to Apple becomes a kind of action. And the agents can reason about whether that's a good idea or not, depending on how to maximize their utility.
Sounds promising.